Hello, in this video I'm going to show you the French method for long division being used for division of polynomials. So the first thing is the French method for showing long division is laid out quite differently to the British method or the standard algorithm that you may be familiar with. So I'll just give you an example with simple numbers so that you can see what I'm talking about there. So if I was taking 30 and dividing it by 4, I would lay it out like that. So I have the dividend 30 and I have the divisor 4. And then I consider what is a multiple of 4 that is less than 30. And in this case, 28 is a multiple of 4 that is less than 30. That's 4 times 7. And then I do a subtraction to see what's left. And that leaves 2. So in this method, the 4 different components that I see here are this 30, which is the divisor, the dividend. The 4 is the divisor. This 7 is the quotient, or the result of that division. And the 2 here is the remainder. So it is read in a clockwise sense, that you start with the whole value that you are dealing with, and then what do you divide it by, what is the result, and is there any remainder? Okay, so let's look at one with a polynomial to see how that applies. So the first example we're going to look at is x squared plus 8x plus 12. So a trinomial. And we're going to divide that by x plus 2. So we are dividing out groups of x plus 2. Like that. And I'm going to extend this bar down. And I find that because of that vertical line, it helps to keep the parts of the work organized. Better than the British system where it sort of snakes down the page in a kind of stairs orientation. Okay, so the first thing I'm going to look at is what would I have to multiply this x by to get x squared? And that's going to be an x. So I'll write that down once. So that gives me my x squared. X times 2 is 2x. So this binomial that I just wrote is the product or the multiple of x plus 2 times x. Draw a line under that. And I'm going to subtract this binomial from the trinomial that I started with. The first terms have now gone away. X squared minus itself is nothing. 8x minus 2x is 6x. And I'm going to bring down this 12. That's what I have left over at this point. Now I'm going to look again. X plus 2, does it go into 6x plus 12? Starting with the first term, if I multiply x by 6, I will get that 6x. So that's good. That term will cancel. 6 times 2 is 12. And when I subtract the binomial from the 6x plus 12, which was my remainder in that middle step, the result is 0. So with a remainder of 0, I have a perfect factor situation. Okay, no remainder. Which means that over here, x plus 2 times x plus 6, and the sign is important. Both of these are positives. So therefore, the factored form of x squared plus 8x plus 12 would be x plus 2 times x plus 6. And I could verify that answer by multiplying it out again and seeing that indeed it does simplify down to that trinomial. Okay, let's look at one more. So this time I'm going to divide x squared plus 4x minus 21 by x minus 3. So this little L shape that I've just drawn, I like to think of it like I've started with a large packet of things, various things, and I'm separating out, like I'm scooping away and separating out groups of x minus 3. Continue that vertical line, like that. So I need to look at the first term as x, multiply it by x. That will give me x squared minus 3x as my binomial in that first step. Subtract that from my original trinomial or 3 terms. First term is now eliminated. I've got 4x minus 3. That's 7x. As my linear term. And then drop down that minus 21. X minus 3 goes into 7x minus 21 7 times. Positive 7. 7 times negative 3 is negative 21. So again, this example has a 0 remainder, which means the factors are x minus 3, x plus 7. Equals that original trinomial, which can be verified using FOIL or multiplication distribution. Okay, we're going to do a couple more. X squared minus x minus 6 divided by x plus 2. So we're dividing out or separating out groups of x plus 2. If I take x times x plus 2, that's going to create that first term, plus 2x. Subtract it from the trinomial that you were given to start with. First term's eliminated. Negative x minus 2x, that's negative 3x. Drop down the minus 6, because that was left over. So here's my remainder at this point, minus 3x minus 6. So it's a partial division. I've divided x groups of x plus 2 away from my original total, and this is what I have left. This is my remainder at this point. So now I'm going to think, what do I multiply x by to get minus 3x? Well, I got to multiply it by negative 3. That will eliminate that term. Negative 3 times positive 2 is minus 6. And as I can see, one term minus itself is 0. So perfect factor in this case again. So x plus 2 and x minus 3 should multiply together to create the original trinomial that we started with. And you can do this to indicate the separation between the individual factors and the binomial factors. Okay, let's do another one. This one will do a coefficient that isn't 1. The first coefficient is 4 this time. So we got 4x squared minus 2x minus 6. And we're going to divide that by 2x plus 2. Same first step. I'm going to extend that vertical line to keep things organized. And then I look at the first term of my divisor, that's 2x. 2x times what is 4x squared? Well, I'm going to have to multiply it by itself. So 2x. So that's going to result in 4x squared plus 4x. and I'm subtracting that binomial from the original total. First term is eliminated, the x squared term is eliminated. Minus 2 minus 4 is minus 6x. Drop down this negative 6. That's what's left over, remaining at this point. And then I look again. How many 2x's go into negative 6x? Minus 3 of them. Negative 3 times 2 is negative 6. And again, a value minus itself is 0. So, factored form of 4x squared minus 2x minus 6 is 2x plus 2 times 2x minus 3. And you could verify that as well. So the inevitable question at this point would be, well, what if it doesn't factor? What if it isn't something that can be divided perfectly? That's not a problem. You can still use this method quite effectively. So let's look at one like that. Leading coefficient 6x squared minus x minus 7. And we're going to divide this one by 3x plus 1. So how many times does that 3x go into that first term? It will go into x times. That results in 6x squared. And then 2x times 1 is 2x. And I'm subtracting the binomial from the original total. My remainder, negative 1 minus 2 is negative 3x. And I still have that negative 7 remaining. I haven't done anything with that yet. Okay, how many times does 3x go into negative 3x? It goes in once, but negative 1. Negative 1 times 1 is negative 1. And again, it's a subtraction. So the negative 3x minus itself, that's gone. Negative 7 minus minus 1 is negative 6. So in this case, I have a remainder of negative 6. So in order to represent that result, I would write 3x plus 1 times 2x minus 1 and minus 6 divided by 3x plus 1. So that last division of negative 6 divided by 3x plus 1 doesn't result in a whole number or a nice even value. So I leave it as a fractional expression. And again, you could use distribution and verify that answer.